Okay, so I hope I'm live now. Just let me know if I'm live and if I'm audible to you. Just give me a quick thumbs up if you are able to hear me. Just a quick thumbs up if you can hear me. Yeah, sure, Rohit. I'll talk in English. That's not something that basically I have any problems with. Okay. So there are a couple of questions that people have already asked over here. Okay, I'll read those questions in a minute. Like somebody has asked, can we get basics of DP over here, and all the other questions that we have over here. Hmm. Okay, okay. Perfect. Okay, so let me quickly connect this part. Pen digitizer over here. I have decided a few questions that I want to discuss today. So let me quickly take to you that. Let me quickly take you to that part. Apart from that, I can see a lot of people are asking whether the webinar would be in C++, Java, or in Python. So the concept that we are discussing today are language agnostic, and it doesn't matter which language we code in. So we are not going to focus specifically on any language. We would be focusing on the concept, right? So let me quickly share my screen so that I can give you a brief agenda on what I want to talk about, right? Okay, so somebody is saying that increase your volume. I hope I'm audible enough. Or do you want me to increase my volume, increase the baritone, or increase the sound? Okay, okay. Does that help? Okay, perfect. I hope now things are perfect. Okay, so this was your event that we are going through right now. And as you can see over here, there was an option called Go to Classroom. Those who have registered for the event, they can see that there was an option called Go to Classroom. And as you click on the Go to Classroom button, you would go inside and you would be able to see this part. And this was the resources which were given to you. And over here, a note was given to you, and we have done two webinars initially. We have already gone through and we have already done two webinars over here. So I just wanted to briefly discuss about those webinars as well. So I have written things that this is third webinar in that series. So I wanted all of you to go through those webinar, and I had provided you the notes as well. So even if you have not gone through these concepts, I would strongly suggest that after this webinar is over, go through these concepts so that you are able to understand what dynamic programming is, and you are able to capitalize on all the concepts that we have already discussed in first two webinars. Today would be a webinar which is in succession to the last two webinars. And even if you are coming on this webinar for the first time, then also I'll discuss the concepts in such a way that you would be able to follow. But still, I would like to suggest you that go through the first two webinars as well after this webinar is over, and attempt these questions as well. I have written 4 or 5 questions over here. I've given 4 or 5 questions over here. You go and attempt these questions, right? Okay. So this was the first thing that I wanted to talk about. The second thing that I want to talk about today's question. So today we are going to talk about those three things only. The way we have solved questions in the earlier webinar, we have solved questions using recursion. Then we have memoized it, and then we have tabulated it. That was the way we were solving this question. Today, what we are going to do is we are directly going to jump to tabulation. We are going to solve much harder questions, much difficult questions, and we are going to directly jump to the tabulation part. Right? Today, we are going to do that. And I have taken these three questions. I'll share the link to these problems as well. So the questions that I have over here is, the first question that I have is maximum sub-array sum. You can quickly go to Coding Ninja's Code Studio if you want to attempt these questions, and then go to practice interview problems. And over here, okay, I have been logged out. Over here, what you can do is you can quickly search for maximum sub-array sum, and you can quickly search for longest increasing subsequence, and you can quickly search for palindromic partitioning. These are the three questions that we are going to discuss today, right? Apart from that, what we are going to do is we are going to focus on the questions today. We are going to focus on only these three questions today. And you have to ask interesting questions. The people who will ask interesting questions in the comments today, we will be giving Amazon vouchers to them, right? So we would be specifically focusing on the type of questions that you are asking in the comments today. And those people who would ask interesting questions or good questions, then we would be having three winners, and we would be delivering Amazon vouchers to them. And so I recommend you to focus on the questions, the type of questions that you are asking. There should be an insight to your question, right? And this happens in Israel. So what happens in Israel is that once the student comes back to his house, his parents ask, what is the interesting question that you asked today in the classroom? So because of the pressure from the parents, students have to ask interesting questions in the class. And because they ask interesting questions in the class, teacher has to study and they have to teach better. So that's the most important thing that we are going to focus today also. So ask interesting questions, and the most interesting questions would be rewarded. So we would be taking three winners, and we would be announcing that at the end of the webinar. Yeah. So perfect. So I hope everything is sorted so far, and we can start with the webinar, and we can start with the first question. Any questions I would be happy to take, right? Yeah, perfect. Okay. Sure. So Ayushman is asking how long this webinar would be. To quickly answer you, we are targeting these three questions. As soon as we are done with these three questions, we would wrap up this webinar, right? And we would not be coding. We would be explaining the question in an elaborate manner, and then we would be writing the pseudocode, right? Okay, perfect. So let me start with the webinar then. Okay, so let me quickly start my open board. And now let me start with the first question that I have. So the first question that I have over here uh, is the maximum subarray sum. So let me quickly explain this question to you. And then I would request you to, if you already know the answer, please try to answer that in the comments. But first, let me try to explain you this question. So let me quickly go to the test cases that are given to us over here. So the test case that's given to us over here is 9, 1, 2, 7, minus 4, 3, 2, minus 10, 9, and 1. So let me quickly take this from here. Okay. Okay. Yeah. So this is the sample input that I have over here, right? And over here, what do they mean by this question is that there are these elements which are given to you, right? 1, 2, 7, minus 4, 3, 2, then minus 10, 9, and 1. These are the array elements which are given to you. You have to find the maximum subarray sum. You have to find the maximum sum of continuous set of characters. I hope you understand what a subarray is, right? So subarray is continuous set of integers, right? A continuous subpart of an array. So we have to find the continuous set of integers which yield the maximum sum. So over here, the maximum sum is 11 as they have given, and the explanation for that is that the maximum sum 11 can be found for these integers. right? For 1, 2, 7, minus 4, 3, and 2. So these are the elements. If you find the continuous sum of these 6 elements, you will get the maximum sum, right? So that's the first example which they have given us. The second example which they have given is it is basically that the element that I have over here is the array element that I have over here is 6. Sorry, 6 are the number of elements, and the array elements are 10, 20, minus 30, 40, minus 50, and 60. And I have to find the maximum sum. And the maximum sum obviously over here would be 60. And what is that maximum sum? Where exactly you can find that maximum sum? 60 alone, which is kept at the end, is the maximum subarray sum, right? I hope you have understood the question, right? So Ankit is saying that use Cadence Algo. Yeah, of course, I would use Cadence Algo, but we have to focus on three things. Some people may not know what Cadence Algo is. Some people may not understand, or some people may not know the solution to this question. So we have to understand why behind this question, that what exactly is Cadence Algo and what exactly is done in it, right? So we have to understand this part. So the first thing that I want to ask you all is that, have you understood the question? If you have understood the question, then I can go ahead and I can talk about the solution, right? So you are given an array of elements and you have to find subarray with the maximum sum. You have to find the maximum sum. Perfect. Perfect. Okay, so Vishnu is saying that he has understood this problem. Perfect. Okay, Suraj is asking that please explain the second sample test case. Okay, let me quickly explain the second sample test case. So in the second sample test case, I have 10, 20, minus 30, 40, minus 50, and 60. So what would be the maximum subarray sum? Maximum subarray sum, the subarray with the maximum sum is this alone element 60, right? Is this alone element 60, right? So this is the maximum subarray sum. I hope now you are able to understand, Suraj, right? To answer your question, Swastik, why in the second test case the answer is not 20? It has to be continuous. 60 plus 20 is not continuous. So I have to find maximum continuous sum, right? And to answer the question, Chaitanya, if you are searching for this question, longest common subsequence we have already discussed in the last webinar. So if you want to find longest common subsequence, I would suggest you to go over here and go to classroom. And over there is a link for the second webinar that we did last time in this series of dynamic programming webinars. In this second webinar, we have already discussed about all these things, right? So now we are taking up three new questions. Okay, perfect. Okay, so now let me go to this question. So to solve these questions, I would be using tabulation. I would be directly using, or I would be directly solving it by, you can say, by storage memory, right? So what happens in dynamic programming is there are three ways to solve a problem. The first way to solve to solve a problem is you use recursion directly to solve a problem. The second way to solve a problem is that you can solve that problem, add question bank with the recursion, add a storage with the recursion. So whenever you get a result from recursion, store it somewhere, right? So that's called memoization, adding a memory to your recursive solution. That's called memoization. Then there is a third question. Then there is a third method of solving dynamic programming problems, and that is by directly solving it by bank, by directly solving it by the storage array. So we are going to directly focus on the tabulation part this time. We have already solved many questions by recursion, then memoization, and then tabulation. Today we are directly going to the tabulation part. And this is the thing that you have to also focus on, directly solving on the tabulation part. This is where the actual DP lies. So there are three steps if you want to solve any question directly by tabulation. So what are the three steps? First, you have to assign a meaning. First, you have to create that storage array, and you have to assign a meaning to a storage. right? I would discuss more on that. Don't worry about these parts. So the first step is add storage and assign a meaning to it, right? Second is you have to decide the direction in which that question has to be solved. You have to decide that once you have the storage and once you have the meaning, you have to decide in which direction I have to go and in which way I'll get the solution to the problem. And third and the last method that we have is, and third and the last step that we have is, you have to travel and you have to solve the problem. These are the generic three steps that we have. So let's suppose this is the problem that we have over here, right? So the problem that we have over here is I have to find subarray with the maximum sum, right? Let me keep these three steps at a corner. Let me quickly keep these three steps at a corner, and we will refer these three steps again and again. So the first step which is given over here is storage and meaning. So the first step that we have over here is storage and meaning. So let me quickly decide the storage and let me quickly assign meaning to it. So first, let me write the test case again. Second test case was a little difficult for you. So I'll write the second test case for you. Okay. So the second test case is we have 6 elements in this test case, and the elements that I have over here is 10, 20, minus 30. Then I think I had 40, and then I had 50, and then I had 60. These are the elements that I had, right? And I have to find maximum subarray. I have to find subarray with the maximum sum. Answer which is given to me is only 60, right? So first, let's try to solve this question without anything in my mind. So let's not focus on dynamic programming right now. Let's just try to solve this question. So if you have to solve this question, what would be the method that you would use? I think the method that you would use would be brute force solution, right? So the brute force solution that I have over here would be start with 10, and find all the subarrays that I can start with 10. So all the subarrays that would be starting with 10 are 10, 10, 20, and then 10, 20, minus 30, and then 10, 20, minus 30, and 40. Then the next subarray that would start with 10 would be 10, 20, minus 30, 40, and minus 50. And then the last subarray, which is starting from 10, would be 10, 20, minus 30, 40, minus 50, and 60. So let me quickly write all the subarrays that I have over here, right? So I have 10, 20, minus 30, 40, minus 50, and 60. These are all the subarrays which are starting from 10. So list down all the subarrays that I have which are starting from 10. Then list down all the subarrays which are starting from 20. So subarrays which are starting from 20 are 20 minus 30, then 20 minus 30 and minus 40. Sorry, it's not minus 40, it's just 40. And 20 minus 30, 40, and minus 50. And at the end, I have 20 minus 30, 40, minus 50, and 60. Now, so on and so forth, you can write all the subarrays which are starting with minus 30, write all the subarrays which are starting with 40, minus 50, and 60, right? And find maximum out of all those subarrays. That's the brute force that I can do, right? That's the brute force that I can do. So this is the naive approach that I can think of. But if I talk about the time complexity of the solution, we are taking the first element and traversing the whole array with it. We are taking the second element and we are traversing the whole array with it. So we are traversing over each and every subarray. So the operations, the number of operations that we are doing over here are roughly of the order of n square, because the number of subarrays that I have over here would be n into n plus 1 divided by 2. So the complexity is order of n square. I hope you understand this part, right? So the solution that I have written over here, as Ujjwal is rightly mentioning, it's of the order of number of subarrays, right? So just to answer a question which Sayantani Gupta was asking, that if we have not seen previous webinars, can we go ahead with this webinar? I would like to answer Shantani Gupta to you. Basically, you can go ahead with this webinar. But I would recommend that after going through this webinar, see the previous two webinars as well. Whatever I would be teaching today, I will make it as simpler as possible, but I would recommend go through these webinars as well, the previous webinars as well. Okay. Uh, so the first thing that I would like to talk about is the brute force solution. I hope you have all understood the brute force solution. Now let's talk about the next part. What if I can create another array over here? So I'm trying to create storage and meaning now. Now I would like to try to find the DP solution to it, or I'm trying to find a more optimal solution to it. So what if I can find the maximums like this? So all these subarrays which are starting with 10, let's suppose their maximum is X, right? Let's suppose all these subarrays which are starting with 20, let's suppose their maximum is Y. All these subarrays which are starting with 30, let's suppose their maximum is Z. And let's suppose all these subarrays which are starting with 40, their maximum is A. Sorry. And let's suppose all these subarrays which are starting with minus 50, their maximum is B. And all these subarrays which are starting with 60, their maximum is C. Right? So let's suppose I create another array. Right? I create another array. So the size of this array is 6. So I will create another array and its size would also be 6. Right? So let me quickly rub part. What I'm going to store over here is I'm going to store maximum of all the subarrays which are starting with 10. Over here, I would be storing maximum of all the subarrays which are starting with 20. And over here, I would be storing maximum of all the subarrays which are starting with minus 30. And over here, starting with 40, over here, starting with minus 50, and over here, which are starting with 60. And let's suppose the elements that I have over here are X, Y, Z, and A, B, and C. Then what would be my answer? What would be my answer? My answer would obviously be maximum of X, Y, Z, and A, B, C, right? So that's the point that I want to talk about. Let me elaborate on this part again. So let's suppose, let me write all the subarrays which are starting with 10. So let me again write all the subarrays which are starting with 10. So the subarrays are 10, 10, 20, then 10, 20, minus 30. Let me quickly write that because that is being repetitive. We have already discussed about that. So let me quickly write that again. Okay. And I need to write all the subarrays which are starting with 20 as well. So let me quickly write all the subarrays which are starting with 20. So what I need to do over here is I need to see something over here. I need to see something over here. There is some overlap over here. If somebody tells me that find the maximum of all the subarrays which are starting with 10, and if somebody tells me find maximum of all the subarrays which are starting with 20, I can say that let's suppose, obviously this is the small problem, right? The number of subarrays that I have over here are 5, right? The number of subarrays that I have over here are 5 and the number of subarrays that I have over here are 6. Obviously the smaller problem is this, right? Again, one other thing that you can see over here, there is a definite overlap, right? This is the overlap that you can see. All these elements that I can see over here, these are all the subarrays which are starting with 20. So I can definitely say that this is the bigger problem and this is the smaller problem, right? So what we have to do is let's try to assume that the answer to this problem you already know. So answer to the smaller problem, assume that you already know, right? So tell me, what is the maximum subarray sum of all the subarrays which are starting from 20? So the maximum subarray sum of all the subarrays starting from 20 is obviously this subarray is of sum 20. This subarray is of sum minus 10. This subarray, the sum of this subarray would be 30. Sum of this subarray would be minus 20. And sum of this subarray would be minus 20 plus 60. It would be 40. So obviously the maximum of out of all these is 40. So you know the maximum of all these elements. So can you find maximum of all these elements? So if you know maximum of all these subarrays which are starting from 20, now can you find maximum of all these subarrays which are starting from 10? It's pretty easy. I have already shown you that there is a definite overlap over here. So if we know maximum of all the subarrays which are starting from 20, can you find maximum of all the subarrays which are starting from 10? So anybody who would like to answer? Yeah, perfect. So Anikrit is saying 50, which is correct, right? Because we know that maximum of all these subarrays is this subarray. Maximum of all these red shaped, red encircled subarrays is 50, right? And we have appended 10 in front of them. सबके आगे हमने 10 ही तो लगाया है. So सबके आगे 10 लगाया है, तो obviously 10 plus maximum of all these would be 50. Sorry, 10 of this is 40, I think. This is 40, sorry. And we have appended 10 in front of it. So obviously the maximum of all these subarrays would be 50, right? But one thing you have missed over here. What we have missed over here is this part. If you are finding maximum of all these subarrays, finding maximum of all these smaller size subarrays, finding maximum of all these subarrays which are starting from 20, and if you are appending 10 in front of it, you have covered this subarray, 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 but you have left out this subarray, right? You have left out this subarray. It may happen that sometimes this is even bigger than out of the 5. It may happen that that this element is even bigger than some of these elements. So let me give you an example, right? So Ayush has correctly mentioned that it may happen that 40 is negative, right? So let me quickly showcase you what Ayush is saying. So there is a small answer and there is a big answer. So this time the answer to the small is positive, which is 40. But it may happen that the answer which is coming from the smaller problem, it may happen that the answer is 20, right? And the element that we have appended over here is the array element that we are talking over here is, let's suppose it's 5, right? So if I take and if I blindly add 5 in front of minus 20, then my answer would be, my maximum subarray sum would be minus 15, which is wrong. If I keep this array of 0 alone, then my answer would be 5, which is bigger than minus 15. So always getting in touch with the answer of the smaller sub problem is not the right answer, right? So what I can say over here is that if we know the answer of the small problem, let's suppose the answer of the small problem is, let's suppose it's X, and let's suppose we have to solve the big problem from it. So my answer for the big problem would be max of array of I have to take that element alone also. And I have to talk about array of I plus X. I have to take all these two conditions in consideration, right? So that's why I wanted to talk about this part. So if you want to solve the big problem, you have to have the answer of small problem, and the big problem can be solved by maximum array of I, comma array of I plus X, right? Now let's see which all parts we have already covered and what are the parts which are still left. So we have taken the storage array, right? And we have assigned to the meaning of one of the storage cell as well. What will this storage cell would be storing is, let's suppose the name of the array is DP. So what would be DP storing is, DP would be storing maximum of all the subarrays which are starting from array of I. So it would be storing maximum of all the subarrays which are starting from I, from ith index, right? So that's what this cell would be storing. That was the first thing that we had to solve. We had to create the storage and we had to assign a meaning to it. The second most important thing that we had to do was we had to get the direction. So what is the bigger problem? So obviously the indices would be 0, 1, 2, 3, 4, 5. And the elements in the array that I have over here are 10. यहाँ पे 10 है, यहाँ पे 20 minus 30, over here I have 40, over here I have 50, and over here I have 60. So area of zero का answer, this is the bigger problem. It depends on answer of 20. Answer of maximum of all the subarrays which are starting from 10 depends on maximum of all the subarrays which are starting from 20. This depends on this, obviously, right? I hope you understand this part. I have already written over here that big depends on small. And so dp of I depends on dp of I plus 1. So this depends on this, and 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 this depends on this, right? So the direction in which I have to solve is I have to solve from smaller to larger, right? So what is the smallest problem? If you can quickly talk about what exactly, what according to you is the smallest problem over here? Is dp of 0 the smallest problem, or dp of 5 the smallest problem? I think the smallest problem over here is dp of 5, right? As Ayushman is rightly mentioning, that the smallest problem that we have over here is dp of 5. Swastik, I'll come back to your question. First, let me explain this question. So why dp of 5 is the smallest problem? And if somebody is saying that dp of 5 is the smallest problem, and I agree with him that the dp of 5 is the smallest problem, then the direction to solve this question would be this. So you always solve from the smallest problem to the largest problem, right? You always go like this, right? So thank you, everybody. Everybody is answering dp5 perfectly right. Now let's try to find what would be the answer of dp5, and then from that I'll find the answer for dp4, and then dp3, and then dp2, then dp1, and then dp0, right? So what is dpi? Maximum of all the subarrays which are starting from ith index. So dp of 5, what would be dp is maximum of all the subarrays which come fifth index. How many subarrays are starting from fifth index? There is only one subarray which is starting from the first index, 60. There is only one subarray which is starting from 60. So there is no other contender. अगर आपकी क्लास में एक आदमी होगा पेपर, आप ही अपनी क्लास में फर्स्ट आओगे ना, हर बार के एग्जाम्स होंगे, सब में टॉप करोगे. सो दैट्स द मोस्ट इंपॉर्टेंट थिंग दैट वी डू. इफ यू आर अलोन, देन यू वुड बी द मैक्सिमम ऑफ ऑल द सब एरेज. सो D5 का आंसर मुझे पता है, एंड आई कैन क्विकली राइट ओवर हियर, right? Let me quickly complete this, Nitish, and then I'll get back to you. I have a one comment from Swastik as well, which I need to address. Okay, so dp5 is 60. Now, from this big and small formula that we have written, quickly try to solve d5, right? So dp of 5 की वैल्यू मेरे पास 60 है. अब dp of 4 की वैल्यू क्या हो जाएगी? It would be equal to minus 50 plus 60, comma minus 50 alone, right? Right? So I hope you are able to understand this part. Let me quickly write the formula over here. dp of I would be equal to max of array of I of I plus 1, right? Because dp of I plus 1 is the small answer that I have, and dp of I is the big answer that I'm trying to solve. Array of I plus dp of I plus 1, or of I alone. So over here, if I can quickly out, what would be the answer for dp of 4? Either minus 50 alone or minus 50 plus 60. So obviously the answer over here would be 10. Minus 50 plus 6 would be a more, you can say it would be a more wiser, right? Now let's talk about dp of 3. dp of 3 depends on dp of 4. So it would be either 40 alone or plus 10. 40 plus 10 would be a wiser choice. So the answer would be 50. Now dp of 2, it would be either minus 30 alone or minus 30 plus 50. Obviously, 30 plus 50 would be a wiser choice, right? Over here, what would be the answer? The answer would be dp of 1 would be either 20 alone or 20 plus 20. So obviously 20 plus 20 would be a wiser choice. So the answer would be 40. Over here, what would be the maximum? So obviously the maximum would be either 10 alone or 10 plus 40. Obviously the answer would be 10 plus 40. राइट सो जितने भी सब एरेज थे जो 10 से शुरू हो रहे थे उनका मैक्सिमम कौन था 50 all the sub arrays which are starting from 20 what was the maximum 40 all the sub arrays which are starting from 30 unka maximum 20 tha so on and so forth and what would be the maximum of all these sub arrays maximum of these individual champions right ये मेरे इंडिविजुअल चैंपियंस हैं और चैंपियंस का चैंपियन मेरा आंसर हो जाएगा right so my answer would be maximum of this array which is 60 right I hope you have got this part right yahan ye wala jo answer hai ye mera maximum hai right now let me talk about okay okay so there are comments that my voice is cracking so is there any problem with the internet let me quickly see if there is a problem with the internet what is the speed at which my internet is going currently okay quite fairly good I think right 20 mbps kind of 20 mbps I think it would be able to take the load of this webinar right okay perfect it's perfect now okay so to answer your question Rohan yeah I'm explaining Kadans yeah so this is Kadans algorithm only but what I want to talk about over here is that this is the way you have to solve these problems so if you want to solve any problem using tabulation first you have to make a storage and then you have to assign a meaning to that storage right that's the first thing that you have to do then you have to find the direction in which the problem has to be solved right you have to decide the direction in which the problem has to solve and then you have to travel and you have to solve the problem these are the three steps that we are going to solve right you don't have to mug up this solution as Kadans algorithm or any other solutions. You have to arrive at the algorithm. You don't have to mug up the solution. You don't have to rote. You don't have to rote learn the algorithm. You have to focus on the algorithm. You have to understand why behind the solutions. So these are the three steps that we are going to use all the three problems right like in this case we assigned the meaning first and first we made a storage array then we assigned the meaning that dp of I would be maximum of all the subarrays from I then we tried to find the direction that what would be big what would be small and what would be the direction to solve it and the direction was this and then we traveled and we solved the problem right yeah I hope you were able to understand that yeah perfect somebody is asking to take another example so to answer your question Gaurav there is no other alternative like this is the best solution that we know to solve the question this is called Kadans algorithm and Kadans algorithm is the best solution that we have to solve this problem okay and this solves the problem in a single traversal in order n right Uh, now there are a few comments that I want to talk about. Tanya is asking that if I want to find the starting and the ending indexes, starting and the ending elements of the subarray, then how do we find out, right? Yeah, so but Tanya, an interesting question, and I would say that we are focusing on interesting questions today, and that would go right at the top. That's an interesting question. There is one question that Swastik was also asking. I would like to take that question as well. So let me quickly go to Swastik. Okay. Swastik is saying, what if someone types zero everywhere, right? So if there is zero everywhere, then what is the solution that you are going to give in this case? So what if someone types at the end he has written -1 as well? So obviously at that point of time, we are going to at that point of time, it depends on how you are solving the question, Swastik, right? The maximum subarray sum obviously would be equal to 0, right? And then if you are if you are asking me what would be the maximum subarray sum, it would be any individual elements, right? It could be this, or 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 it could be this, right? If you are taking the first maximum subarray sum from behind, then it would be this. If you are finding first maximum subarray sum from starting, then it would be this. It depends on which direction you are solving the question, right? We will convert the given array and we will convert to DP array. What would be the DP array for this array? Obviously, the DP array would be 0, 0, 0, 0, and -1, obviously. And let's suppose now I have to find maximum of all the elements that I have in the DP array. And let's suppose I'm traversing from behind. So then this would be the first maximum that I get. If I'm traversing the DP array from ahead, then this would be the first maximum that I get. It depends on from where you are traversing, right? So interesting questions, Swastik. And okay, so Swastik is saying that if they are all zeros, then obviously then obviously my answer would again be 0. It depends on in which way I find the maximum in the DP. If I'm finding the maximum from behind, then this 0 would be answer. If I'm finding 0 from ahead, then this is my maximum. This would be my maximum, right? Now a little question that Tanya has asked, a great question, which Nagraj has again reciprocated. Uh, so Acha, Nagraj is trying to answer the question also. Okay, so we have to find the indices of the maximum subarray sum. So let's take another example and let's try to solve this question. So the another question we have over here is, the other test case that we have is 1, 2, 7. Then -4, we have 3, we have 2. And then we have -10, we have 9, and we have 1, right? And we have to find the maximum sum, subarray sum over here, right? And we have to find, we just don't have to find the maximum subarray sum, we have to find the starting and the ending indices as well. Obviously, this is the maximum subarray sum that we have. The starting indices would be this and the ending indices would be this. We have to find that subarray as well, right? So let me quickly repeat the array. Let me quickly repeat the whole process again for the people who are not able to understand this problem in the first go. For the people who are able to understand, I would like to give this problem as an exercise till the point I'm solving this test case. Try to find starting and the end indices of the subarray as well. Starting and the end indices, right? That's the most important thing that you have to try to, you have to basically solve it, right? You have to try and basically solve it. Try to find starting and the ending indices. Okay. Aniket is asking, what if there are more than one maximum subarray sum? That I've already answered, Aniket. If there are more than one maximum subarray sum, then obviously it depends on in which directions you are traversing. So let me traverse this array again, and let me try to solve this question again, right? So obviously, according to our algorithm, we will create a DP array like this, right? And like this, okay? DP of I, what would be DP of I storing? DP of I would be storing maximum of all the subarrays which are starting from the ith index. So obviously 1 would come over here, right? Over here, the answer would be 9 alone or 9 plus 1. So obviously the maximum would be 10, 9 plus 1. Over here, maximum of all the subarrays are starting with -10. So to answer this question, I have to take -10 or -10 plus 10. So obviously it would be -10 plus 10, which would be 0. Over here, my maximum would be 2 or 2 plus 0. It would be, I can take any of these two, right? Because the element that I am getting from behind is also 0, right? Then over here, either I keep myself as 3 or I keep myself as 3 plus 2. So obviously I'll keep myself as 3 plus 2. Either I keep myself at minus 4 or I keep myself at minus 4 plus 5. Obviously I'll keep myself at minus 4 plus 5, which would be 1. Over here, the option would be either 7 or 7 plus 1. I will take 7 plus 1. Over here, I can either be 2 or I can either be 2 plus 8. So I would be 2 plus 8, which would be 10. Over here, I can either be 1 or I can be 1 plus 10, which would be 11, right? So the maximum that we get over here, the maximum subarray that we get over here would be 11, right? Now let's try to answer uh, the question which was asked by Tanya. So Tanya was saying, find the starting and the ending indices. There are a lot of ways to find starting and the ending indices. The naive approach that I can get, that find the maximum from this array. The maximum from this array is 11, right? So that means this is the place from where the maximum subarray sum is starting, right? So this is the place from where maximum subarray sum is starting. And you, the sum also, you know, uska sum kitna hai, you know that it is 11. So yahan se start karo और ऐड करना शुरू करो. ये आपका स्टार्टिंग इंडेक्स हो जाएगा मैक्सिमम सबेरे सम का 0th इंडेक्स. और यहां से ट्रेवर्स करना शुरू करो. कितना सम हो जाएगा? 1 plus 2 3, 3 plus 7, 3 plus 7 is 10, 10 plus minus 4 is 6, 6 plus 3 is 9, 9 plus 2 is 11. यहां पर जाके आपका खत्म हो गया ना, यहां पे जाके आपका 11 बन गया. So this is the place where your sum 11 has reached. So that means my maximum subarray sum, which has a sum 11 and which starts at starting index of 0, we can traverse and we can keep on going till my sum becomes 11, and I would be able to find the ending index as well. So this is one way to solve this problem. And another question that was asked by another person, I forgot the name. He said that let's suppose we have another 11 over here. Let's suppose there are more than one maximum subarray sum. Then what would be my answer? It depends on which way you are finding the maximum. So let's suppose you are finding the maximum by traversing in the forward direction. Then obviously the maximum sum would be 11. This would be the maximum subarray sum. If you are trying to find by traversing in this direction, then this would be the maximum. पहले कौन सा maximum पकड़ोगे? पीछे से जा रहे हो तो पहले ये पकड़ोगे, यहां से जा रहे हो तो पहले ये पकड़ोगे, right? Okay, perfect. Yeah. So Rajshekhar is saying that I cannot see the utility of finding starting and the ending index. Okay. Okay. Yeah. Okay. To answer the question, user with the username SFNFF, the way we were solving and we were creating the DP was from right to left. But finding the maximum after DP is created, it depends on us, right? DP को create करने के लिए हम right to left move किया. बट एक बार डीपी क्रिएट हो गया तो डीपी एरे में से मैक्सिमम निकालना तो हमारे ऊपर डिपेंड करता है ना, आगे से फाइंड करें या पीछे से फाइंड करें. Right. Okay, so one last question that I want to take from this question is Divyang has asked this question. So Divyang is asking, how do you identify whether it's a DP problem or not? So you have to ask yourself, DP problem is a problem which has a recursive solution. Then if it has a recursive solution, then, and if you are able to see that there is an overlapping part, if you are able to see that there is a big problem and that big problem has a smaller sub problem, then we would be able to say that this is a recursion problem, right? So if there is a big and a small problem, that means there is recursion in it. Recursion भी ऐसे ही काम करता है. बड़ी problem को solve करने के लिए छोटी का आंसर मंगवा लेते हैं. So if there is a recursion component in it, then there can be DP. There can be a DP. This can be a DP problem. The second is there should be recursion overlap, or you can say there should be recursion overlapping sub problems. सो रिकर्जन का ट्री जब आप बनाओगे उस प्रॉब्लम को सॉल्व करने के लिए, अगर एक प्रॉब्लम को सॉल्व करने के लिए आप बार बार उस रिकर्सिव ट्री के अंदर आप देख रहे हो कि एक सब प्रॉब्लम हैज बीन कॉल्ड अगेन एंड अगेन, देन यू कैन से दैट देयर इज एन overlapping sub problems. At that point of time, you can find the answer of one sub problem, you can store it somewhere, and next time when it asks you the answer of that sub problem, you can quickly go over there and you can find that, right? So there is a scope of optimization. This has been elaborately explained in the first webinar and the second webinar. So if that is a DP problem or not depends on recursion, right? We are not going to discuss on how to solve a DP problem through recursion, and we are not going through that route today. We are going to directly solve it using tabulation, right? So that's one thing that I wanted to talk about. Okay, so perfect. So if there is one person that I can talk about, I think Tanya asked a great question. Then Swastik also asked a very interesting question, and Devang also is asking a great question, and Nagraj obviously is also over there. Okay. Uh, Ishan is asking a great question again. Really interesting questions I am able to get today, and that's the power of interesting questions. If you focus on the question that Ishan has asked, that let's suppose we have to find the minimum subarray sum, right? Then which approach to follow? You can see there are so many problems which can come from a single problem, like finding the starting index or ending index. And like this question which is Ishan has asked, I'm not going to answer that question. That because I'm running out of time, I have to discuss two more problems. But what I can say over here is that Ishan has asked a great question, that what if in place of finding the maximum sum, what if you have to basically talk about, and you have to find answer to a minimum subarray sum, right? A very interesting question, and I must say that others who are trying to listen to this webinar, the other participants to this webinar, I think you should don your thinking hat and you should think around this problem, right? Keep this question as an exercise. Perfect, Ishan. Great question, great question. uh, okay, so the next question that we have is longest increasing subsequence. So I would like you all to read this problem statement for a moment. And till that, I'll read some more problems. I'll read some more statements over here, right? If I can find some more comments, some more interesting comments, then it would be really great. Okay, you can go through the next problem that we have. Please go through the next problem that we have. But kudos to you, Ishan. That's a great question. Okay, perfect. So I think you were able to read the question. Now let's try to move to the explanation of this question, right? Okay. So yeah. So the question that we have here is that we are given an array of n elements and we have to find the length of the longest subsequence. And the elements of the subsequence should be in strictly increasing order. Strictly increasing order means that each term in the sequence is larger than the preceding term, right? Let's quickly jump to the test cases and I would explain you what this problem is exactly asking. And then we have to do the same thing that we have done so far. Right, we are going to do the same thing that we so far. We will first try to assign a storage and we will try to assign a meaning to it. And the second thing, we'll decide the direction to solve that problem, and then we'll travel and solve the problem, right? So the test case that I have over here is, let me quickly take it. Okay. Okay. Just give me a moment. Yeah. So the test case that I have over here is this. Add to the current page. Okay. So over here we are given with these six elements, 5, 4, and 11, and then 1, 16, and 8. Okay. Uh, then we are going to take, we have to find the maximum or the length of the longest increasing subsequence. What do you mean by increasing subsequence? But before going into increasing subsequence also, let me first ask you whether you understand the subsequence term or not. Subsequence, how many subsequence do we have in an array of size n? What is a subsequence? Subsequence is any sequence of elements where the order is maintained, where some elements are coming and where some elements are not coming. So let's suppose one sequence is I have taken 5, I have taken 4, I have taken 1, and I have taken 8. Uh, I can take any sequence of elements. Every element has this choice whether you want to come into the solution or not. राइट सो यहाँ पर मतलब जैसे मैंने एक सीक्वेंस बना दिया 5, 4, 1 and 8. 11 has said that I will not come to the sequence. 16 has said that I will not come to the sequence. So this is one subsequence. Order of elements is very important. Order of elements should be same as the order of elements is there in the given array. So everybody has a choice to come in the sequence or not. Everybody has choice to come in the sequence or not. So I have to find, so subsequence is any sequence of elements where everybody has a choice whether he wants to come in the solution or not. So how many such sequences can be made? Everybody has choice. So simple principle of counting says that this is a choice 2, this is a choice 2, this is a choice 2, so on and so forth. There are n elements. So I think if I want to count the number of subsequences, then by principle of counting, I have to multiply everybody simultaneously. And then since there are n elements, so number of subsequences would be 2 raised to the power n, as Deepak and user with the username Infinity Star is saying, right? So 2 raised to power n. Okay, so now let's talk about it in a bit detail. So now we have understood what is a subsequence. We have to only consider increasing subsequences. So what are increasing subsequences? So those subsequences which have a strictly increasing order. So for example, there is one subsequence called 5, 11, and 16. Everything is strictly increasing in this order. एकदम ascending order में जा रहे हैं. 5, 11, and 16. Similarly, let's take 4, 11, and 16, or let's take दो size का subsequence ले लेते हैं 4 and 2. Everything is in strictly increasing order. So I have to find the longest increasing subsequence over here. I have to find the longest increasing subsequence over here, right? So let's try to solve that question, right? Again, the 3 steps that we are going to do, I have to assign storage, and after assigning the storage, I have to give meaning to that storage. Then second is direction in which the problem has to be solved. I have to see what is small and what is large. So yeah, what is small and what is big. So direction is very important. Last step is travel. I have to just travel and solve this problem, right? So any suggestions would be welcome. If you have any suggestions to solve this problem, then it would be welcome. As we have understood the problem, an array would be given to you, and you have to find the longest increasing subsequence. We have to find the length of the longest increasing subsequence, right? And over here, the length of the longest increasing subsequence would be 3. Either it could be 5, 11, 16, or it could be 4, 11, and 16. Yojit is saying thank you. Okay, Yojit. Shivansh, am I expected to store the subsequence? No, you are not expected to store the sequence. You just have to find the length of the increasing subsequence. Shivansh is asking, okay, Shivansh, I've answered you. Then Rishabh is saying that why this is not a subsequence. 8, 4, 11, and 16. Why this is not a subsequence? This is not a subsequence because order खराब हो गया ना यहाँ पे. आप ध्यान से देखो. 5, 4, 11, 1, 16, and 8. The order in which that you have taken the elements are सबसे पहले 8 ले लिया, फिर 4 ले लिया, 4 के बाद 11 ले लिया और फिर 16 ले लिया. ऐसे You have to go in the order. मैंने 4 के बाद 11 लिया, 11 के बाद 16 लिया, right? Okay, now we have some answers over here. So if you can answer in the same way, storage and meaning, direction and travel and solve, you can answer in the same steps, then it would be really great. Uh, Divyang is saying we can use a stack and attach a condition to put only increasing elements and give the length of the arrays, give the length of the stack. That's an interesting thought, Devang. That's an interesting thought, but it would not give me order n complexity. Order n complexity से नहीं होगा, order n square से होगा, right? मैंने इंक्रीजिंग एलिमेंट्स डाला सिर्फ, लेट्स सपोज 5 से मैंने शुरू किया, सबसे पहले 5 डाला, फिर उसके ऊपर 4 को मैंने नहीं डाला, फिर 11 को डाल दिया इसके ऊपर, और फिर 16 को डाल दिया, फिर मैं किसी को भी नहीं ऐड कर पाया. सो ऑब्वियसली स्टार्टिंग विद 5, द लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस दैट आई कैन गेट इज 3, राइट? देन उसके बाद you can only answer for 5 here, right? That's an interesting thought that Divyang is talking about, and he's saying that make a stack, make a stack, and make a stack, and make a stack for 5, then make a stack for 4, keep 4 at the end, then traverse only in the right direction. Then after 4, take the next greater element, which would be 11, then take the next greater element, which would be 16, right? That's an interesting thought we have, right? So for 4, the longest increasing subsequence would be 4, 11, 16, which would be 3, right? Then let's talk about the next element that we have, and which is we have 11. So let's keep 11 at the end, and then we will keep 16 at the top, and the length of this subsequence would be 2, right? Then we are going to talk about 1, right? So 1 के ऊपर फिर 16 आ जाएगा, right? And then what we see over here is that 16, there is only 2 length subsequence that I can form, right? There is this is a thought, but I think this is not going to take into consideration all the sequence, right? Devang, to answer your question, uh, why this question is not correct, right? Why this question is not correct, why this approach is not correct. First is that for solving this problem, I have to use n stacks for n elements. That's the first problem that I have. I'm using humongous amount of energy space, right? So order n square space I'm using. That's pretty bad. Dilip, I'll come back to you. I'll come back to all the comments that you have written. First, I just wanted to answer Devang. So Devang, over here we have seen that we are using n stacks for all the n elements, but it's still not the correct answer. For example, let's suppose 5, 4, 11, 16, and 1 and 8 are given to you, right? And you would create a stack starting with 5th element. So let me write some more elements over here. Let me write 6 over here. Let me write 7 over here, and that's it. And let me write 9 as well, right? So according to you, your stack will have 5, and after that have 11, and after that it will have 16. So according to you, starting with 5, the longest increasing subsequence that can be formed is of length 3. You would say 5 से 11 पे जाओ, 11 से you would say 16 पे जाओ, 16 के आगे आप जा नहीं सकते. But according to me, there is a longer increasing subsequence. 5 से 6 पे जाओ ना, 6 से 7 पे जाओ, 7 से 8 पे जाओ, और 8 से 9 पे जाओ. There is a longer subsequence that we have, and the length of the longer subsequence is 5 over here. So that is where your question is going wrong, right? Uh, so perfect. Others, please try to chip in and try to find the answer. Tanya is saying that you have to start from right and check if AI is greater than I minus 1. Okay, okay. Kind of correct. Then Shivansh is saying that can there be duplicate elements in the subsequence? Yeah, there can be duplicate elements. Yeah, there can be duplicate elements. But you have to apply increasing. You have to find strictly increasing subsequence, right? Binary search cannot be applied. Uh, Tarun is saying that move from left to right, move from left to right. And then what you have to do is if AI is greater than AJ, store the value AJ plus 1. Kind of correct. Okay. Okay. Binary search, Dilip is saying, I don't see, Dilip, that you would only be using binary search to solve this problem. There should be something else as well. Okay, Shivans, I hope I have answered your question. Yeah, Ishan written a lot, and he's saying that try to solve this problem this way. He's saying that travel from left to right, right? And he's saying that if array of I is greater than array of j, then what you need to do is you need to create another array which is going to store length of the increasing subsequences. And if I is greater than j, so what you need to do is L of I, you write 1 plus L of j, which is kind of correct. I will talk about it in little bit more detail. I would be using this solution only. Okay. Okay. Okay, Shivyansh has another great question, which is find the longest common subsequence in the two arrays. We'll talk about this after this question. So I hope you all have tried to solve this question. Now let me explain this question to you. Okay. Okay. Okay, so let's first start the first part. The first part is storage and meaning. So the question that I have over here is 5, 4, 11, then I have 1, then I have 16, and then I have 8. I have to find the length of the longest increasing subsequence. What I will do over here is I'll make another given array, right? Now what I'm going to do over here is I have to find the length of the longest increasing subsequence, right? So let's try to name this array as L. And now let's try to assign meaning to this cell, which is L of I. So in L of I, what I'm going to store over here is I would be storing length of longest increasing subsequence, which is ending at array of I, which is ending at array of I. It's very important to create a storage array and assign a meaning to it, right? It's very important because when you assign a meaning to it, then only you would be able to uh, create the solution. You can go ahead in this direction to solve this problem, right? So what I'm going to do over here is I'm going to say a simple problem. I'm assigning the meaning over here. I'm saying L of I is equal to length of LIS, which is ending at array of I, right? So I am going to say that, okay, let me not erase it. Let me just decrease the size, or let me move it below. So at L of I would be storing the length of the longest increasing subsequence, which is ending at array of I. So let me write the longest increasing subsequence, which is ending at array of I for everybody, right? So the length of the longest increasing subsequence for 5 would be 1. 5 पे एंड होने वाला लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस हो सकता है. 5 पे एंड होने वाला सबसीक्वेंस ही एक लेंथ का होता है ना. सो यहां पर 5 आ जाएगा. देन 4 पर एंड होने वाला लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस एक लेंथ का होगा, यहां पे 4 आ जाएगा, राइट? क्योंकि कितने सबसीक्वेंस हैं, देखो कितने सबसीक्वेंस 4 पे एंड होने वाले कितने सबसीक्वेंसेस हैं. 4, एक 4 हो गया और एक 5 4 हो गया, दो ही तो सबसीक्वेंस है. दिस इज नॉट इंक्रीजिंग, राइट? 5 एंड 4 इज नॉट इंक्रीजिंग, सो आई हैव नॉट कंसीडर्ड दैट, राइट? अब 11 की बात करते हैं. 11 पे एंड होने वाले कितने सबसीक्वेंसेस हैं? 11 पे एंड होने वाले 11 पे एंड होने वाले मेरे पास बहुत सबसीक्वेंसेस हैं. आई थिंक 11 पे एंड होने वाले, लेट मी क्विकली राइट, 11 पे एंड होने वाला एक सबसीक्वेंस सिर्फ 11 है, और एक 511 है, एक 411 है। ये भी इंक्रीजिंग है, ये भी इंक्रीजिंग है, ये भी इंक्रीजिंग है। इन सब में से लॉन्गेस्ट कौन है? 511 ले लीजिए या 411 ले लीजिए। सो आई वुड बी टेकिंग, लेट्स सपोज आई टेक 511, राइट? लेट्स टेक 511। उसके बाद 1 की बात करते हैं। सो 1 के लिए लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस सिर्फ एक लेंथ का होगा, एंड इट वुड बी 1। लेट्स टॉक अबाउट 16। So for 16, the longest increasing subsequence, which is ending at array of I, it's very important to learn this term, ending at array of I. Ending of array of I is very important. So which is ending at array of I? It is 3. And what is this length? Its length is 3, and the subsequence is 5, 11, and 16. Or it would be 4, 11, and 16. The longest increasing subsequences, which is ending at 8, it would be of length 2, right? It can either be 5 and 8, it can either be 4 and 8, it can be either 1 and 8. इनमें से कोई भी एक ले सकते हैं. But these are the longest increasing subsequences. Now, after I have solved this problem, after I have found this array, then the problem would be solved, right? Then my longest increasing subsequence, length of the longest increasing subsequence would be 3. And I'm going in this direction, as Swastik has rightly mentioned, right? So I'm going in this direction, right? Direction is very important. You have to create a storage, then you have to assign a meaning to it, then you have to decide for direction, right? Now let's try to solve it in a more elaborate way. We have solved this problem, right? So now let's try to solve this problem in a more elaborate way. Now let's try to find big and small. What is big and what's small, right? You have understood the direction. You have understood the direction, you have understood the storage, you have understood the meaning that I have assigned to it. Now let's try to go in detail, and now let's try to see what is big, what is small, and how I would be solving this big problem from the small solution. Okay, so वो assign करने की कोशिश करते हैं. Let me quickly decrease the size. Okay, and let me put it this way in a corner, right? Okay, let me keep this part as well, and let me keep it there over here. So let's suppose I am over here, right? Let's suppose I am over here. 5 is given to me, 4 is given to me, 11 is given to me, 1 is given to me, 16 is given to me, 8 is given to me. And let's suppose I'm trying to solve L of I, right? So I would be solving in this direction. You have already seen that, right? I would be solving it in this direction. You have already seen that. First, I would be I would be finding the length of the longest increasing subsequence of 5 of the 0th index, which would obviously be 1. Then I would be solving for first index, then second index, then third index, then fourth index, and this fifth index. One thing that we all can agree is that the length, the longest increasing subsequence for everybody would be at least 1. जो इंक्रीजिंग सबसीक्वेंस होता है उस लेंथ में एटलीस्ट एक एलिमेंट तो होगा ना, एरे ऑफ आई तो होगा खुद. सो मैं यहां पर 1 तो सब में पहले ही ऐड कर देता हूं, राइट? सो 1 तो मैं पहले से ऐड कर देता हूं इसके अंदर. उसके बाद अब इस प्रॉब्लम को सॉल्व करना है. अब हम बात करते हैं इसको सॉल्व करने की. लो एल ऑफ आई को सॉल्व करने की कोशिश करते हैं, या फिर लेट्स नेम इट प्रॉपरली एल ऑफ 3 को सॉल्व करने की कोशिश करते हैं. जब मैं एल ऑफ 3 को सॉल्व करूंगा, सो ये तो पहले से सॉल्व हो चुका होगा ना. यहाँ पे क्या स्टोर होगा? यहाँ पे 1 स्टोर होगा, यहाँ पे 1 स्टोर होगा, यहाँ पे 2 स्टोर होगा, और यहाँ पे इनके इंक्रीजिंग सबसीक्वेंसेस भी लिख लेते हैं फटाफट से. इसका इंक्रीजिंग सबसीक्वेंस 5 है, इसका इंक्रीजिंग सबसीक्वेंस 4 है, इसका इंक्रीजिंग सबसीक्वेंस 2 लेंथ का है, 5, 11 या फिर 4, 11. अब एल ऑफ 3 को सॉल्व करने की कोशिश करते हैं. एल ऑफ 3 को अगर मैं सॉल्व करने की कोशिश करूं, so how many people do you think you should traverse, right? You need to find the length of the longest increasing subsequence which is ending at array of I. Array of I की वैल्यू क्या है? array of I की वैल्यू है, array of 3 की वैल्यू कितनी है? 1 है. so वो कौन से सबसीक्वेंस है जिनके पीछे मैं 1 लगा सकता हूं, जो 1 पर खत्म हो सकते हैं, राइट? ऑब्वियसली अभी तक कितने बंदे मैं ट्रेवर्स कर चुका हूं? मैं 5, 4 और 11 ट्रेवर्स कर चुका हूं. इन सबका लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस मुझे पता है. इन सबका लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस, इसका इंक्रीजिंग सबसीक्वेंस 1 लेंथ का है, इसका 1 लेंथ का है, इसका 2 लेंथ का है ना? एंड इसका आंसर मुझे पता नहीं. लेट्स ट्राई टू फाइंड आंसर फॉर 1, राइट? इफ यू आर फाइंड आंसर फॉर 1, देन आई वुड बी एबल टू फाइंड व्हाट इज स्मॉल, व्हाट इज बिग. सो एल ऑफ 3 को सॉल्व करने के लिए मैं यहां से ट्रेवर्स करना स्टार्ट करूंगा. क्या 1 5 के पीछे अप्लाई किया जा सकता है? आई नो द लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस फॉर 5 for this zeroth index element is 1, which is 5. Can I apply 1 at the end? Longest increasing subsequence which is ending at zeroth index, which is ending at 5. Can I add 1 behind it? I can add it. Right? Then the second thing, can I add this 1 behind 4? I cannot add it. Can I add it behind 11? I cannot add it. Right? I cannot add it behind these elements. Right? So iska matlab मैं I cannot add it behind 5, I cannot add it behind 4, I cannot add it behind 11, I cannot add it behind anybody. So that means we cannot add it behind anybody else. So the answer for L of 3 would be 1, right? Longest increasing subsequence which is ending at 1 would need its answer from longest increasing subsequence which is ending at 5, 4 and 11. So isko solve करने के लिए मैं इन सब के ऊपर जाऊंगा, right? So that means L of 3 को solve करने के लिए I needed answer for L of 0, L of 1 and L of 2. These are the answers that I needed. If इसका आंसर 1 था, इसका आंसर 1 था, इसका आंसर 2 था, इसकी वैल्यू लास्ट एलिमेंट की 5, इसकी लास्ट एलिमेंट की वैल्यू 11, इसके लास्ट एलिमेंट की वैल्यू इसके लास्ट एलिमेंट की वैल्यू 4, इसकी 11. I cannot keep 1 behind 5, so इसलिए इसके पीछे नहीं लगा. I cannot add 1 behind 4, इसलिए इसके पीछे भी नहीं लगा, इसके पीछे भी मैं नहीं लगा सकता. So that's why I cannot keep 1 behind anybody else. So that's why the answer of L of 3 was only 1, because alone 1 will form the longest increasing subsequence, right? I hope you are able to understand, right? So let's take another example. Let's suppose you want to find L of 4. So the element at 4th index is 16. You would need L of 0, you would need L of 1, you would need L of 2, you would need L of 3 to solve this question. Element at 0th index is 5. Over here there is 4. Over here there is 11. And over here I have 1. Length is 1, 1, 2, and over here the length is 1. Can I place 16 behind the longest increasing subsequence which is ending at 5? Okay, I can do that. So L of 4 would be whatever value I have for this plus 1. 5 का जो भी increasing subsequence है, 5 का जो increasing subsequence है, which is 5, I can append 16 at the back. So my value would be 1 plus 1, which is 2. Then can I append 16 behind 4's longest increasing subsequence? The ending of the longest increasing subsequence at 4 is 4. I can append 16 at the end. So 416 is answer, right? So the longest increasing subsequence ending at 11 is of length 2. So I can append 16 at the end because 11 se bhi bada hai. So the length would be 3. Longest increasing subsequence which is ending at 1 is 1. I can append 16 at the end, so the length would be 2, but it will not update L of 4, right? So it would be 3. I hope you are able to understand how I am going to solve this problem, right? So now let me write the pseudocode and now let me try to solve the problem. Somebody has rightly asked me that write the pseudocode for this problem, right? So let me quickly write it. I'm writing the elements over here. I'm writing the elements at the top. This is 5, this is for 4, this is for 11, this is for 1, this is for 16, and this is for 8. And this is the L array, right? For solving 2, I would rely on 1 and 0. For solving 4, I would rely on 0, 1, 2, and 3, right? So let me quickly write the pseudocode. The first thing that I have to do is I have to traverse and I have to keep 1 at each and every element, right? I have to write 1 at each and every element. This is something that you are able to understand, right? Then I have to start in this direction. Okay, so let us start in this direction. Obviously, I know for I equal to 0, I already know the answer. So I'm not going into detail. I'm not going to start for I equal to 0. I'm going to start for I equal to 1, right? So for I equal to 1, I'm going to start. Then if you are at any ith index, you have to again traverse from 0 till I minus 1. So let us take an inner loop, and let us take an inner loop where j starts from 0 and it goes up till I minus 1. And let me write two conditions over here. First condition should be that array of I should be greater than j. If array of I is greater than j, and there is another condition, L of I, right? So let's suppose if array of I is greater than array of j, then only I can add array of I behind array of j, whatever longest increasing subsequence that I have for array of j. At the end, I can append array of I, right? Then only I can append it, right? So what I'm going to do is, if array of I is greater than array of j, then I'm going to do something, right? The second condition that I have to talk about is, अगर एरे ऑफ आई बड़ा है एरे ऑफ जे से, जैसे 16 है 11 से बड़ा है, सो 16 11 के पीछे लग जाएगा, राइट? उसके बाद आई हैव टू अपडेट एंड आई हैव टू मेक माय एल ऑफ आई इक्वल टू 1 प्लस एल ऑफ जे, but that I will only do if L of I is smaller than 1 plus L of j, right? If it's smaller than L of j, 1 plus L of j, then update it with 1 plus L of j, right? Then only you do that, right? So this is how you are going to do it for the first, second, for the 0th, first, second, third, fourth. Every index you have to do that, right? You would obviously get this longest increasing subsequence array. L बारा array आपका completely fill हो जाएगा इस pseudo code से. So this would be 1, this would be 1, this would become 2, this would become 1, this would become 3, and this would become 2. इतना करने के बाद then quickly traverse to the whole array and find the longest increasing subsequence, which is 3, right? Yeah. So उसके बाद maximum element find करना है. ये पूरा array बनाने के बाद इस तरीके से, उसके बाद आपको maximum element find करना है. I hope I was able to explain you the problem. Now let me go to the comments, right? First of all, a hello from Anuj. Hello, Anuj. Okay. Yeah. So I probably have missed a few comments above. So let me quickly read the comments. I would request all of you to write as many comments as possible. Whatever questions that you have regarding this problem, the longest increasing subsequence question that we have just solved, then just let me know. Right? We are done with this question. I would be taking questions right now, and then we would be move. Then we would move to the next question. Okay. So one question that Shivansh is asking, Shivam is asking, Shivam has just retracted his comment. So he was asking that what if we have to print the subsequence? So if we have to print the subsequence, then that's an interesting problem. We can do that. We can do that, but for that we have to take another array. We have to take array list as well, right? uh, we have to create an array of array lists. We have to create an array of lists, right? So one interesting question which was asked by Shivam, which he has just retracted. Okay, he's written at the end. What if we want to print the sequence also? This is one question that I want to talk. Okay, Kunal is asking, can't we traverse from right to left? Obviously, we can uh, traverse from right to left, but for that, Kunal, what you have to do is you have to basically change the meaning that you have given to that cell. What the meaning that I gave was find the maximum or find the longest increasing subsequence which is ending at array of I. आप जिस तरीके से ट्रेवर्स करना चाहते हो उसके लिए मीनिंग चेंज हो जाएगा. उसके लिए मीनिंग हो जाएगा find the longest increasing subsequence which is starting at index I. So meaning would be little changed. So that is one thing that I wanted to tell you. Meaning change हो जाएगा. Ishan is asking that question, in case if you are willing to print the elements, then the length. In that case, would we need recursion only or we would need DP? So we can solve it by DP as well. Let me talk about this problem. So same array is given. This time I don't just have to print the maximum length, I have to print the elements as well. So 5, 4, 11, same array that I had. So this is the array that I had. And what I'm going to do is I'm going to take two arrays this time. One is the small integer array. Let's name it DP, or let's name it L, the name that we have been given so far. And the another array that we are going to use is list array. So I am going to store lists over here, right? I'm going to store the list over here. So I'm going to store lists over here. So an array of list has to be done. And a 2D array has to be taken over here, right? So to begin with, I'll add 1, 1, 1 in all the elements. Then I'll add 5, 4, 11, 1, 16 and 8 over here. So obviously हर लिस्ट का स्टार्टिंग एलिमेंट, हर लिस्ट के अंदर हम 5 ऐड कर सकते हैं, 4 ऐड कर सकते हैं, 1 ऐड कर सकते हैं. दिस वुड बी द एंडिंग एलिमेंट दैट आई वुड हैव, राइट? Or what I can do is, let's not fill right now. Let's not fill right now. Let's only fill for 5, because इसका आंसर तो मुझे पता है, यहाँ पे 1 है और यहाँ पे 5 आएगा, राइट? अब 4 की बात करते हैं. सो 4 का आंसर यहाँ पे 1 ही रहने वाला है, सो यहाँ पे 4 आएगा, राइट? नाउ लेट्स टॉक अबाउट 11. So for 11, I can say that the length of the longest increasing subsequence after the complete traversal came out to 2, and it was contributed by 5 and 4. But first, let's take 5. So what I'll do is I'll take the list of 5 and I'll append 11 at the end. Over here for 1, I was not able to contribute it from any. I was not able to contribute from any. I was not able to contribute from any preceding elements, neither from 5, neither from 4, neither from 11. So I would only write 1 over here. For 16, the contribution came from 11. So I'll take the list of 11 and I'll add 16 at the end. For 8, the contribution came from 5, 4 and 1, right? So I'll take the first list and I'll add 8 at the end, and the length would become 2. That's how we are going to talk about. And the complexity that Kunal is asking, complexity would be order of n square only. For solving any I am traversing again from 0 to I minus 1, right? So that's why I think that I would be able to solve this question in order of n square, right? Time complexity I've answered. Okay, thank you Tanya to answer that. Okay, coming to the last question. Coming to the last question, which is palindromic partitioning, right? Okay. So Kunal, the time that you are asking is the time which is mentioned over here, the time limit. That's the time of server which is given to you. सर्वर का 1 सेकंड गिवन है आपको. 1 सेकंड के अंदर आप इस प्रॉब्लम को सॉल्व कर सकते हैं, ठीक है? सो सर्वर का 1 सेकंड आपको गिवन होगा, राइट? ओके, ये टाइम कॉम्प्लेक्सिटी नहीं है, दिस इज जस्ट द टाइम विच विल बी गिवन फ्रॉम सर्वर टू यू, राइट? टाइम कॉम्प्लेक्सिटी हमारा सॉल्यूशन का ऑर्डर n स्क्वायर है, राइट? लेट मी एक्सप्लेन दिस प्रॉब्लम टू यू विद द हेल्प ऑफ द एग्जांपल. ओके, थैंक यू दीपक. Now Shivansh is again asking this question, that find the longest common subsequence in given two arrays. Again, a great question from Shivansh. Okay. So let me quickly write about that somewhere. So there are two subarrays which are given to you. There are two arrays which are given to you. So over here, let's suppose there is 5, 4, then I have 11, then I have 1, then I have 16, and then I have 8. And then let's suppose I have 30, there is another array which is given to me, 13, 11, 14, 16, and then 15. Like these are the two arrays which are given to us. I have to find the longest increasing subsequence. Like over here, the longest increasing subsequence I have is 11 and 16. So two size subsequence is also there in this first array, and it's also there in the second array that I have. That's an interesting question. People, you should try to solve this question. Like, this would be an exercise for you. Try to solve this question. Find the longest increasing subsequence of two arrays. Find the longest increasing subsequence. Find the longest common subsequence of two arrays, right? You can take hint of whatever that we have learned so far, or you can take hint from all the resources that we have provided you in the classroom attached to this, right? If there are notes over there, and there are links to the previous two webinars, right? I have already discussed about longest common subsequence of two strings in the last webinar. In the last webinar that we did, we discussed about longest common subsequence of two strings. So you have to apply learning of that into longest common subsequence of two arrays. You can do it from the knowledge that you have got from longest common subsequence. You can solve it from LIS also, right? Try to solve it. Try to solve it. Uh, Shivansh, I would not be able to take this question right away because we are running out of a time a little bit, because I have to discuss a third question as well. Uh, if we get some time, we would try to discuss this question, right? We will try to discuss this question. Okay. Okay. So now let me move to the next question that we have. Okay. So the next question is palindromic partitioning, right? Shovik is asking that please take my question. Shovik, what was your question? Can you please add? Okay, so I've already answered that question, Shovik. What is the time complexity? Time complexity would be order of n square for LIS. The question, the approach that we used would have the LIS approach, right? Okay. Now in this question, we have to find partitioning, right? So let's try to solve this question that we have over here. Okay, let me take a new page. This is the last question that we will have for this webinar. Okay, okay. So over here, what we have is we have BA, BAB, CBA, DCE, and DE, right? And DE. Like, these are the elements that we have. I have to find the minimum partitioning. I have to find the minimum palindromic partitioning, right? So let me quickly explain you what the minimum palindromic partitioning means. So it means that, let's suppose you have this string which is given to you, right? So if this is the string which is given to you, then what would be the minimum palindromic partitioning? You have to partition the string in such a way that the all the elements between the partitions are palindrome. So just say I can keep a partition over here, I can keep a partition over here, I can keep a partition over here. These are the three partitions that I'll do. अब इस पार्टीशन में A है, दिस इज अ पैलिंड्रोम, इसमें B है, दिस इज ऑल्सो अ पैलिंड्रोम, इसमें एक स्ट्रिंग है, दिस इज ऑल्सो अ पैलिंड्रोम, एंड इसके अंदर एक स्ट्रिंग है एंड दिस इज ऑल्सो अ पैलिंड्रोम, right? So these are all the palindromes that I have. I've added three partitions and I can see all the strings in between the palindrome, in between the partitions are palindrome, right? There is another way in which I can create the partition, right? This was the string, right? I can create the partitions in this way. This is also a palindrome. This is also a palindrome. This is also a palindrome, right? So अभी दो partition में ही काम हो गया. So दो partitions के अंदर काम हो गया, right? So the minimum partition in which I can do palindromic partitioning for this string would be 2. And similarly, let's try to partition for this string. ये बहुत बड़ा string है, इसके लिए partition करने की कोशिश करते हैं. So I think this is 1, right? Okay. Then I think the next partition that we can do over here is I think C B A D C, right? I think we cannot do anything around that. So एक partition तो हमें शायद यहाँ पे करना पड़ेगा, right? And then second partition we have to do over here. Third partition I think we have to do over here, and fourth partition I think we have to do over here only. Now there are, अभी हम 4 से ज्यादा partition कर रहे हैं यहाँ पर, राइट? सो हम यहाँ पे 4 से ज्यादा पार्टीशन कर रहे हैं. इसका पार्टीशनिंग कोई बता सकता है क्या? आई एम नॉट एबल टू फिगर आउट कि 4 पार्टीशन में हम किस तरीके से इसको सॉल्व करेंगे. इसका पार्टीशन बता दो फर्स्ट टेस्ट केस का. सेकंड टेस्ट केस इज नितिन. Obviously it's a complete palindrome, so I don't have to partition anything. Then the third string that I have is a B B A C. इसमें कितना पार्टीशन करना पड़ेगा? I think one partition. I have to do only one partition. I have to do over here, right? So this is also a palindrome and this is also a palindrome. So इसके अंदर एक पार्टीशन लगेगा, इसके अंदर 0 पार्टीशंस और इसके अंदर 4 पार्टीशंस लगेंगे. Okay. So somebody with the username Infinity Star is saying, Utkarsh is saying that partition after BAB. Okay, so let me quickly write this again. Okay, this is BAB. Thank you, Utkarsh. This is BAB, AB, CBA, CBA, DCE, and then at the end it's EDE, right? So Utkarsh is saying make a partition over here after BAB, then make a partition for ABCBA, then make a partition for D, then make a partition for C, right? This is what Utkarsh is suggesting, and I think we would all agree on this, right? We will all agree on this, right? So perfect. I think we are able to figure out now. We are able to figure out the part that Utkarsh is mentioning. Okay. So this was the part I was mentioning to you. Let me quickly make it a little small and let me write it this way. I hope you are able to understand the question. Swasti is asking if Nitin is like this. If Nitin is like this, small n. If this is capital N, this is. So it's given in the question, Swastik, that everything would be, it's given in the constraints that there would be uppercase characters only. So I think it's given in the question. Yeah, the string will only consist of uppercase English alphabets without any spaces. So we cannot take small n. That's not in the premise of our question. And if it's a small n, then I would not be able to say that n and n are same. Right? So let's not go into that detail. Let's just say that everything would be uppercase letters, and then let's talk about this question. Right? This question has 2 prerequisites. This question, if you want to solve this question, there are 2 prerequisites. There are 2 prerequisites to solve this question. And this is the same question. This is the same approach with which I would be able to solve this problem, with which I would be able to solve matrix chain multiplication as well. Right? So matrix chain multiplication is also something that we are going to we are going to solve it using the same way, right? Right. As so there are 2 prerequisites. Let's try to solve this problem. Let's try to solve A, B, B, A, and C. Let's try to take our last example, right? So let's try to solve this question. Let's first try to solve it recursively. So if you have to solve it recursively, then what you have to do? So it's one of the premise of this question. So I have to discuss the recursive solution. So just try to listen the recursive solution a little more patiently. So I will make one partition, right? So somebody tells me that find somebody tells me to find the recursive solution, or somebody tells me to find the solution of how many partitions should I apply in this string. So I would say that let me apply only one partition. Let me apply this partition at A, and then let me apply this partition for B, 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 A, C. So I'm applying only one partition, and basically A, B, B, A, C, and A. These are two separate. I have applied one partition over here like this, right? Then what I'm going to do is I'm going to apply another partition at the end of B. I'm exploring all the choices that I have, right? I'm exploring all the choices. So I have to, if I have to apply only one partition, then where exactly I'm going to apply that partition? So one partition I'll apply after A. If after not A, then I'll apply it after B. If not after B, then I'll apply it after A, B, B, A, C. These are all the choices that I can have. Or I can say A, B, B, A, and at the end I can have C. So somebody has asked you find the minimum partitions in which A, B, B can be palindromically partitioned. What I would say is कि मैं अपनी तरफ से एक partition add कर देता हूं. इसका minimum partition आप निकाल के ले आओ, इसका minimum partition आप निकाल के ले आओ. And I have added one partition from my end. Similarly, I am saying that I have added this partition from my end. Find the minimum partition for this and find the minimum partition for this. इनके लिए minimum partition आप found करके ले आओ. एक partition मैंने यहाँ लगा दिया, इसका minimum partition लेके आ जाओ, इसका minimum partition लेके आ जाओ. ये ऐसे ही मैंने कहा कि मैंने partition यहाँ पे लगा दिया, इसका minimum partition लेके आओ, इसका minimum partition लेके आओ. These are only the 4 options that I have. इसका minimum partition अब चार से जिसका सबसे कम पार्टीशन होगा वो मेरा आंसर हो जाएगा. लेट्स ट्राई टू सॉल्व इट. सो ए का मिनिमम पार्टीशन कितना होगा? ऑब्वियसली इसका 0 होगा. बीबीएसी का मिनिमम पार्टीशन क्या होगा? सो बीबीएसी का मिनिमम पार्टीशन बताओ आप क्या होगा इसका. आई हैव टू अज्यूम दैट द आंसर टू दिस सब प्रॉब्लम वुड कम. सो बीबीएसी का मिनिमम पार्टीशन आई थिंक 2 होगा. सो इसका मिनिमम पार्टीशन 2 होगा. So the total number of partitions, if I apply the partition over here, would be 0 for this, 2 for this, and 1 that I have applied. So total number of partitions would be 3. Over here, the number of partitions would be 2. Over here, the number of partitions would be 1. So total number of partitions would be 1 plus 1 plus 2. The number of partitions would be 4. Over here, the number of partitions would be 1, and over here there would be 1. So एक यहाँ पे और एक इसका. So number of partitions would be 3. Over here, the number of partitions would be 0. Over here, the number of partitions would be 0. And 1 partitions from my name. So, ये मैंने एक partition अपने नाम का यहाँ पे लगा दिया और it would become 1. So, अगर मैं partition यहाँ पे करता हूँ तो minimum number of partitions कितने हो जाएंगे? 3. अगर मैं यहाँ पे partition लगाता हूँ तो minimum number of partitions 4 हो जाएंगे. If I apply the partition over here, then the minimum number of partitions would become 3, and if I apply the partition over here, then the minimum number of partitions would become 1, right? So that's why my minimum number of partitions would be 1. I'm exploring all the choices, right? So that's how this question would be solved. So this is my problem and this is my sub problem. I hope you are able to get that part, right? I'm keeping it aside. Just let me know if you have understood the recursive approach or not. I just want some quick thumbs up. I just want some quick questions if you have on this recursive approach to solve this question, right? So have you understood this recursive approach? This is the problem that I have. This is the big problem that I have. And these are the smaller sub problems that I've divided, right? So Dilip is saying thumbs up, Tanya thumbs up, perfect. So मैं सिर्फ बड़ी प्रॉब्लम से सारी रिकर्सिव ऑप्शंस एक्सप्लोर कर रहा हूं और इस तरीके से सॉल्व करने की कोशिश कर रहा हूं, राइट? Vijay is giving another approach to solve this question. Vijay, probably that would not help us solve this question. विजय कह रहे हैं कि जितना भी पैलिंड्रोम है ना उन सबका लेंथ को माइनस कर दो. सो यहाँ पर जो फर्स्ट प्रॉब्लम दैट आई हैड, द फर्स्ट question that I had, B A B A B, C B A and D C and E D E. इसमें आपके हिसाब से तो we would take this, but we didn't take this. We made the partition over here. So that's why it is not necessary that we blindly take all the palindromes and we blindly add this part, right? So perfect. So many people are saying that they are able to understand. Okay. So that was the first prerequisite for this question, right? The second prerequisite for this question is that you have to create this diagonal array, a diagonal DP array, right? So I would create this diagonal DP array, and let me quickly create the diagonal DP array, and then I would be able to talk about that in little more detail. So over here I would write A. Okay, so let me write it in capital letters. Over here I'll write A. Over here I'll write B, A, and C, right? And over here I'll write A, B, A, and C. And the indices also I'll write, this is 0, this is 1, this is 2, this is 3, this is 4. I'm making a 2D array, a Boolean 2D array, 0, 1, 2, 3, and 4. This is the second important thing that we should have over here. This is the second prerequisite that you should know for solving this question, right? So perfect. Let me quickly make the 2D array, right? Shivansh is asking something. Uh, Shivansh is asking that if the given string is a palindrome, then we directly return 0, right? How can we do this in case of matrix chain multiplication? Over there is something else, right? If there is a single string, then we return 0. So there is a different base case over there. But what I wanted to suggest is the kind of approach that I'm going to use, like the kind of partitioning that I'm doing over here, same kind of partitioning would be done in matrix chain multiplication. So that's why I wanted to tell you about that. So this is the first thing that I wanted to talk about over here, this recursive approach that I wanted to talk about. Then the second thing that I want to talk about is that in this array, you can talk about any cell. So let's suppose I'm talking about this cell. This cell is 1, 2. That means this cell is storing the information for the string which is starting at the first index and it is ending at the second index, right? So any cell which is I comma j, it means that the string which is starting from I and ending at j. So 1 comma 2, that means in the given string, the string which is starting at 1 and which is ending at second index, which is b and b. So it is storing the information for that string. And what it is storing? It is storing whether the string which is starting at first index and which is ending at the second index, whether it's a palindrome or not. If I would have stored true, that means that substring is a palindrome. If I would have if I would not have written true, or if I would have written false, that means it's not a palindrome. So at dp of I comma j, I'm storing whether the substring which starts at I and which ends at j, whether it's a palindrome or not. I would be using it to solve this problem. I would be using this recursive solution and I would be using this storage array to solve this problem, right? So let us quickly try to build this and then we would be able to solve this. So obviously these cells would contain false. These lower diagonal cells would contain false. Why would they contain false? Because let's take any cell. So let's take this cell. What is this? This is 3 comma 1. Does it make any sense? Any substring which is start at third index and which ends at first index, it doesn't make any sense, right? So it doesn't make any sense. String is starting at third index and ending at first index. So obviously all the cells before this would have the answer, right? That's the first thing that I wanted to talk about. Over here, a dp of I 0 0. This diagonal talks about all the cells which have single element, all the substring which is made up of single element. This is talking about 0 0, which means only A. This is talking about only B. This is talking about only B. This is talking about only A, and this is talking about only C. So this is talking about A. This is talking about A. This is talking about quickly right at the corner. This is talking about B. This is talking about A, and this is talking about C, right? So obviously over here I have true at all the places, right? Kartika, I would come back to a question. Just give me a minute. Let me quickly fill this 2D array first. So over everywhere in the lower diagonal cells, I would write false, right? And in the main diagonal, I'll write true everywhere because they are denoting single element substring. This is denoting AB, this is denoting BB, this is denoting BA, and this is denoting AC. And this is denoting ABB. Let me quickly write this, right? This is denoting from 1 to 3. From 1 to 3, it's BBA. From 2 to 4, it is BAC. From this, it's ABBA. And this is BBAC. This is from 0 to 4, which is ABBAC, the complete string that we have, right? Obviously, we can quickly find that for the main diagonal, I'll write true everywhere. For the second diagonal, if both of the characters are same, I'll write true, otherwise I'll write false. So over here, there would be false, and over here, there would be false. I'll quickly filling this up. I don't want to talk about this part because generating this, I've already explained this in the longest common subsequence part, or sorry, the question that we did last time was longest common substring, longest palindromic substring. I've already discussed this part. So do you want me to discuss this part again? I hope you have followed up till here. The main diagonal would be true, of course, and the second diagonal that we have over here would be false, true, false, and false, right? If both of the characters are same, I would keep true, and if both those characters are different, then I would keep false. Do you want me to explain how this diagonal, this diagonal, and this diagonal has to be filled? We would traverse all the 2D arrays diagonal wise. So let me quickly know whether you want me to explain this problem, right? DP of ij stores whether the substring I comma j is a palindromic substring or not. It stores true and false. Do you want me to elaborate on that part? Just let me know. So Ishan is saying that there is no need. Okay. So let me quickly solve it then. If you want to know how this diagonal matrix was made, I think you can go to the last webinar and you can find it over there. So I'm quickly doing it. For ABB, obviously it would be false. For BBA, obviously it would be false. And over here, it would be false, right? Uh, Over here, obviously it would be false because ABBA is not a palindrome and BBAC is not a palindrome. For ABBAC is also not a palindrome. So I'll write false over here as well, right? Uh, so Tanya is also saying no need. Sonali is saying that we need the solution to this 2D array. Sonali, I would recommend you to go to the previous webinar that we did. It's already there. I've shared the link over here in the classroom of this event. So I would recommend you to see the previous webinar. We have elaborately discussed longest palindromic substring. We have already discussed this, how to create this in order of n square in longest palindromic substring problem. Right. So these are the two things that I wanted to talk about. So we have created these two things, right? We have created these two things, and let me keep it in smaller in size. Let me keep it in smaller in size, and let's keep it over here, right? We would be using these two to solve our question, right? Okay, one thing that Rohit is rightly mentioned is that ABBA is palindrome. Okay, so let me quickly write this true over here, right? Perfect. Now it's perfectly fine. Okay, thank you. Shivansh, I got your question. And this is the first prerequisite that I wanted to talk about. And this is the second prerequisite that I wanted to talk about. Now there is two questions which are hanging. One is which Kartika is asking. Kartika is asking that what if what if we have the same number of minimum number of partitions? Which partition which should we consider between that? Uh, Uh, you have to just write the minimum number of partitions, Kartika. So if we have two partitions which are giving the same number of minimum partitions, I think the answer would be one, right? So let's suppose I have A, B, 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 A, right? Or you can say that there is no partitions over here. Uh, but let's suppose there are two ways with which we are getting the same number of minimum partitions. So you have to just print the minimum number of partitions. You don't have to print that, right? You don't have to print the partitioned string. Shivansh, to answer your question, how to find the smallest next palindrome of a number, I think that is not in conjunction to this question, I think. Uh, so I think you are asking that if I have 1331, you need me to find the next palindrome of this number. That's an interesting question, but again, this is not in context with the question that we are talking about here. So we have to ask interesting questions to each other. That I agree. For that, we have vouchers at the end, which I'll disclose. But we have to stick to the question that we are asking, right? We cannot go haywire. Utkarsh is saying, while computing the table for the second prerequisite, is there a better way than order of n cube? Yes, I have discussed the solution of order n square, and I have discussed in the webinar, last webinar, the second webinar, where I was solving this problem called longest palindromic substring, and over there I have explained the solution. Order n square is the solution to solve this problem. Okay, Utkarsh. Okay. So that's one thing that I wanted to talk about. Okay. So now let's try to solve this question, right? So let's create table again. Okay. I would be using the 2D array table to solve this problem, right? Okay. Let me keep it over here. Yeah, perfect. Okay, so let me quickly write. I would be making a similar table to the table that I have made in second prerequisite, A, B, B, A, C, and A, B, B, A, C, right? Okay. So let me quickly create this table, and we have to assign a meaning to it. Now we are trying to solve the original problem that we had. The original problem is, what's the minimum number of partition in which you can solve the problem? What's the minimum number of partition in which you can palindromically partition the string? So over here, what I can see is that the indices that I have over here is 0, 1, 2, 3, 4, and over here I have 0, 1, 2, 3, and 4. If I'm trying to solve any cell, let's suppose that cell is I comma j. For example, this is 2 comma 2. This cell is 2 comma 2. So this dp of 2 comma 2 indicates that the substring which starts at 2 and which ends at 2, right? So I have to find the answer for this substring which starts at 2 and which ends at 2. So starting at 2 and ending at 2, the substring would be B, right? So this is the substring that I have to solve, right? So in this cell, at dp of ij, what I'm storing is, what is the meaning of dp of ij? dp of ij means the cell. dp of ij means the substring which starts at I and which ends at j. The substring which starts at I and which ends at j. What is the minimum number of palindromically partition, like what's the minimum number of partitions that can be done to that substring which starts at I and which ends at j? So minimum number of palindromic partitions which are done to the substring which starts at I and which ends at j, right? That's the question. That's the meaning which is assigned to dp of ij. Obviously, this would not make any sense because of the obvious reasons that I had explained you over here. So I can write 0 over here, or I can write -1 over here, whatever you want to write, right? This would be an integer 2D array, right? Then first I'll traverse the main diagonal. So when I traverse the main diagonal, so obviously over here I'll write 0, right? I already know, right? The answer to this would be 0, because in main diagonal, what are the substrings that I have? What is the substring that I have over here? There is only A, there is only B over here. This is B, and this is A, this is C. Obviously, these are all my palindromic substrings. These are all my palindromic substrings. That's why the number of partitions that I have to do over here would be 0. And over here there would be AB, over here there would be BB, over here there would be BA, over here there would be AC. And let me quickly write over here, this would be ABB, this would be BBA, and this would be BAC, this would be ABBA, and this would be BBAC. And this last one would be the complete string ABBAC, right? So obviously in the main diagonal, I'll write 0, 0, 0, 0, right? So then what we need to do over here is we need to talk about AB, right? So AB, for AB, AB, if it's a palindrome, for example, BB is a palindrome. So my number of minimum palindromic partitions would be 0. If it's not a palindrome, then I would say that my answer would be equal to 1 partition. AB would have 1 partition because it's a 2-length substring. I would need 1 partition to palindromically partition it. Obviously over here also there would be 1, and obviously over here also there would be 1, right? Now let's talk about ABB. Let's talk about ABB. So what are the number of ways in which I can partition it? So I'm talking about this premise over here, the first premise that I gave over here. So there are 2 ways in which I can partition it. I would say एक partition इधर मार देते हैं A के बाद ABB, and the second way in which I can partition is AB and B. These are only the 2 choices that we have, right? Let's try to find where are these elements ABB and ABB. क्वेश्चन तो यही है ना, अगर आपको कोई बोलता है कि ABB के मिनिमम पैलिंड्रोमिक पार्टीशंस फाइंड करके दो, तो आप क्या बोलोगे? आप यही तो बोलोगे, मैं अपने नाम का एक पार्टीशन A के बाद लगा देता हूं, एक पार्टीशन में AB के बाद लगा देता हूं. तो आप इसका मिनिमम पैलिंड्रोमिक पार्टीशन निकाल दीजिए, इसका मिनिमम पैलिंड्रोमिक पार्टीशन निकाल दीजिए. फाइंड द मिनिमम पैलिंड्रोमिक पार्टीशंस फॉर दिस एंड दिस. Similarly, find the minimum palindromic partitions for this and this, right? फिर पूरे का मिनिमम पैलिंड्रोमिक पार्टीशन निकाल लीजिए, पूरे का मिनिमम पैलिंड्रोमिक पार्टीशन निकाल दीजिए. That's one way to partition it. That's another way to partition it. इन दोनों में से जो मिनिमम होगा वही मेरा आंसर होगा, right? Let me quickly take this call. Just give me 2 seconds. Just give me 2 seconds. There is a call that I have to take. Okay, so I hope you are able to hear me, right? Yeah. So I hope you are able to hear me now. I had a small call which I had to take, and that was about that I have to wind up this webinar before 9:15. So let me quickly explain you this part. सो ABB को सॉल्व करने के लिए मुझे यहाँ पे लगाना पड़ेगा और यहाँ पे लगाना पड़ेगा. सो यहाँ इसके लिए बात करते हैं. A के लिए आंसर कितना है? 0. BB के लिए आंसर कितना है? 0. और मेरे नाम का एक पार्टीशन. सो द नंबर ऑफ पार्टीशंस वुड बी 1, राइट? एंड सिमिलरली फॉर ABB this would be 1 partition and this would be 0 partitions, and एक मेरे नाम का partition, so there would be 2 partitions. ABB के लिए what is the minimum number of partitions? The minimum number of partitions would be 1, right? So the minimum number of partitions would be 1. So ABB का आंसर 1 होने वाला है. But let's try to find this in this 2D array, in this matrix, in this table. ABB, where are A and BB? Let me change the color. This is A and this is BB, right? This is A and this is BB, right? So then let's try to find where is AB and B. This is AB and this is B, right? So what you have to do is एक A and BB का sum करके +1 करना पड़ेगा. One competitor would be 1. The other would be AB plus B का sum करना पड़ेगा और उसमें +1 करना पड़ेगा. The other competitor would be 1. Out of all these competitors, the answer would be minimum of all these competitors. So my answer would be 1. Similarly, let's try to find for BBA. BBA would be partitioned into BB and A, and it would be partitioned into B and BA. So B and BA, this is B and this is BA. So these two are taken in the first one. And in the second partition, I have taken B and A. So these two are taken. So the first competitor says that the number of partitions would be 0 plus 1, the number of partitions would be 2. The second says the number of partitions would be 0 plus 0 plus 0 plus 1, it would be 1. So my answer would be minimum of all these, which would be 1. राइट. सिमिलरली बीएससी को सॉल्व करवाओ. बीएससी के लिए पार्टीशंस फाइंड करने की कोशिश करते हैं यहीं से. सो पार्टीशंस क्या होंगे, बी और एसी. एक पार्टीशन तो ये होने वाला है, देखो ये एलिमेंट और ये एलिमेंट, और सेकंड एक हो जाएगा बी और एसी, और दूसरा पार्टीशन हो जाएगा आपका बी ए और एसी. सो आई थिंक यू आर एबल टू अंडरस्टैंड. फॉर एग्जाम्पल ये इसके लिए फाइंड करने का कोशिश करते हैं. आपको इस रो में फर्स्ट एलिमेंट लेना पड़ेगा और इस कॉलम में आपको फर्स्ट एलिमेंट लेना पड़ेगा पार्टीशंस फाइंड करने के लिए. सो एक पार्टीशन तो इसका फर्स्ट एलिमेंट और इसका फर्स्ट एलिमेंट हो जाएगा ए एंड बी बी ए सी. दूसरा पार्टीशन हो जाएगा यहां से इसका सेकंड एलिमेंट और यहां से इसका सेकंड एलिमेंट, विच वुड बी ए बी एंड बी ए सी. एंड यहां से इसका फर्स्ट एलिमेंट और इसका फर्स्ट एलिमेंट, विच वुड बी ए बी बी, एंड यहां से इसका थर्ड एलिमेंट ए बी बी, और यहां से इसका थर्ड एलिमेंट विच इज ए सी. सो यू कैन सी द फोर्थ एलिमेंट फ्रॉम हियर एंड फोर्थ एलिमेंट फ्रॉम हियर, विच इज ए बी बी ए एंड सी. राइट. सो इस तरीके से आपको इसमें पूरा ट्रेवर्सल करना है. राइट. सो दैट्स हाउ यू हैव टू सॉल्व दिस क्वेश्चन. So you have to do this calculation, right? One element you have to take to solve dp of ij. What you have to do is you have to take one element from the row and you have to take one element from that column, right? That way you have to traverse. इसका करने के बाद ये लिया, ये एलिमेंट लेना पड़ेगा, इसका थर्ड एलिमेंट, उसका थर्ड एलिमेंट, इस तरीके से आपको एलिमेंट्स लेकर आपको ये dp of ij सॉल्व करना पड़ेगा. That's exactly how matrix chain multiplication works. Right? That's exactly how matrix chain multiplication works. So I hope you would be able to solve. I have to wrap up this webinar very quickly and I have to disclose the webinars winners for the Amazon vouchers as well. So I think you would be able to solve this problem now. I think this was enough explanation for you, right? I'm sorry that I have to wrap up this so urgently and so abruptly. I have to end it. I'm sorry, but I hope you would be able to solve this problem given that I've explained you so much, right? So I just wanted to give out the names of the winners. I think Tanya would be one of the winners of the Amazon voucher. Then Shivansh would be another winner that we would have for Amazon vouchers. Shivansh Bhatia, and then it was a tough call. Like there were a lot of people, like Utkarsh was answering so much, then Kunal was answering so much. There was a user with the username SFNFF who was answering so much. Divyang, Swastik was answering also. But I have chosen Tanya, Shivansh, and Ishan. So please send us your details and we would send you the vouchers. Please send your details at navdeep@codingninjas.com and we would send you the vouchers. I'm sorry that I have to abruptly end this webinar, but I hope you would be able to code now, right? And if you have any more doubts also, then also you can quickly connect with me at navdeep@codingninjas.com, right? So I hope you would be able to solve this problem, this palindromic partitioning problem, right? I hope you were able to get the gist of the problem, right? So thank you, people. Thank you so much. Thank you so much for joining. Sorry that we have to end so abruptly, but I hope you were able to learn those 3 problems and you have to apply those things, right? Okay, you have to apply all those 3 steps. Those 3 steps were, first you have to find the storage and assign a meaning to it, then you have to find the direction, and then you have to travel and solve it, right? Please apply these things and you would be good to go, right?